I'm Lori Meggs.
And I'm Bill Hubscher. Welcome to Focus on Marshall.
Today we're going to visit a couple of labs that have been pretty busy lately.
That's right, they've been doing a lot in the support of the return to flight effort, so let's head right on over to building 4487. We're out of the Instrument and Payload Systems Department offices, and we're joined by Patrick McManus. Patrick, first of all, tell us specifically what branch you're a member of.
We're a member of the Parts Packaging Fabrication branch, and specifically we are in charge of EEE Parts Engineering and Analysis for Marshall Space Flight Center projects.
Well, tell us a little bit more about what your team does.
We actually qualify parts for spaceflight use, and we also do, on the analytical side, we perform failure analysis of EEE parts and also upstream parts for spaceflight use.
And you've got some labs here as well, right?
Right. We do all the tools we need for failure analysis. They include environmental scanning electron microscopy. We have all light optics microscopy laboratory. We have a cross-sectioning laboratory for metallography. We also do real-time radiography, and we also do Fourier transform infrared spectroscopy.
Can we take a look?
Yes, there's two enhanced capabilities that we recently were able to procure, and one of them's the Phoenix Nanomex real-time radiography system, and the other is the environmental scanning electron microscope.
So which one are we going to look at first?
We're going to look at the Phoenix Nanomex radiography system.
Okay, let's head over there.
I'm at the real-time radiography lab with Terry Rowland. Terry, thanks for being with us today.
Hey, Lori.
Tell me about what you're doing here.
We perform EEE parts failure analysis for Marshall Space Flight Center, and this is the latest piece of equipment that we have to help us accomplish that. It's made by Phoenix, and it's a nanofocus X-ray machine. This is a world-class machine. There's only a few of these things located throughout the world, so it's a unique capability that we have to help us perform failure analysis on different types of parts. What we have on the inside here is an engine cutoff sensor. It's called an eco sensor, and it's one of the things that's called the shuttle launch to be scrubbed. And so what we'd like to do is we'd like to show you what one of these things looks like on the inside.
All right, you can do that with this computer right over here, right? You can really dissect what you're looking at with this eco sensor.
That's correct. When he turns this on, like I say, this is an X-ray machine, so the X-rays pass completely through the material, and different materials have different types of X-ray densities, and so we can look at this and determine which parts are different types of what their makeups are. But we can also look for things like fractures and broken wires and things like that. And you can see him kind of increasing the magnification here, and what he's looking at is something in this eco sensor that's called a terminal assembly, and it's what we believe is causing the problem with these sensors. This sensor is also sitting on what's called a CNC table. It's a computer numerically controlled table that allows us to make very precise measurements, and we're going to use this table in future screenings for sensors that are going to be put in external tanks.
So a lot of return to flight work going on in this lab, and you also have another lab you want to show us, right?
That's correct. We have a scanning electron microscopy lab I'd like to show you.
All right, let's check it out.
Now we've moved across the hall to another lab, and Terry joins us to tell us about this machine.
Yeah, we're in the light optics and scanning electron microscopy lab, and this is another piece of equipment that we have that's new here to do failure analysis with. It's called an environmental scanning electron microscope, and it's the latest we have in our non-destructive evaluation techniques. With old electron microscopy, you had to gold coat samples, and that tend to change the characteristics of your sample because you always had to shoot through the gold. Now with this new type of machine, we can actually put samples in there that are even wet without having any trouble of charging or anything like that. So this is a non-destructive technique. We can put a sample in there, take it out, load it back into whatever it was, and it'll behave just like it did before you put it in there.
Great, thanks, Terry. Let's take a quick look now at what's inside. Russ Abrams is sitting at the controls. Russ, tell us what we've got inside the microscope.
This is an eco sensor terminal post assembly. It's at about 65x magnification. And let me take it in about 700 or so. We'll see what it looks like.
So you can get really tight with this.
In there and look at the markings on the post and see what happened to it when it was being assembled.
So here we can see the tight picture of the sensor. What's over on this side?
This is an elemental analysis that can tell us exactly what materials this sensor is made from.
So not only you get an up-close picture, but you can actually tell what metals, etc., the material is made of?
That's correct, Bill.
Fantastic. Great. Thanks a lot, Russ.
Thank you.